see how to insert phi functions using the dominance frontiers. We do this for each variable, for each local variable and for each compiler-generated temporary, not for global variables, not for heap memory locations, for local stack allocated variables and compiler-generated temporaries. Okay, so we go through all variables and insert phi functions for that variable, one variable at a time. And the variable iteration, it keeps track on which variable we are working with. It's incremented once. We increment it when we will process a new variable. And to check if we already have inserted a phi function for this variable, each vertex has an attribute, has already, which is set to iteration when we insert the phi function in that vertex. The reason we need that is that there can be several reasons for inserting phi functions. Suppose we have an assignment in vertex 3 and in vertex 6. Then both these vertices have 5 in their dominance frontier, so both would want to insert a phi function in 5. Obviously, we can only have exactly one phi function for A in 5. We also have a work list of vertices that we need to process. And to check if we have already been put on the work list for this iteration, then we remember which iteration it was when we put it on the work list. So we start with setting the work list to empty and process one variable at a time. And we start with initializing this work list with all the vertices which have a normal assignment, like this one. Then we will also consider phi functions as assignment, since they are assignments, and extend this work list with nodes which have a phi function. Okay, so we set this work attribute and add the vertex to the work list, and then until the work list is empty, we take just one vertex there from it and consider each vertex in its dominance frontier. If we have already inserted a phi function for that variable in that vertex, we don't do anything. Then, but if we have not, then we, if we haven't, then this is less than the iteration. So then we insert the phi function at the beginning of V. Okay, so we say it got the phi function in this iteration. If it's not in the work list, if it's not been in the work list for this iteration, then we add it to the work list. Okay, so using this explicit counter, iteration, and the attributes work and has already, is how the algorithm was presented in originally by the researchers at IBM in 1991 in the journal article. So this is much more efficient than using some kind of search or lookup function to determine whether we need to perform these operations. And the speed of an optimizing compiler is extremely important. We expect compiling a file within a few seconds at most. Of course, there are some optimizations which can take much longer, such as several hours, but normally we want the compilation to be fast, and therefore we need to make use of um, fast algorithms and fast implementations of these algorithms, which, by the way, C and C++ are the preferred languages for implementing optimizing compilers.